Next we'll see static acceleration error constant kb and k suffix a. Ka. So the steady state error of the system for the unit parabolic input r of t is equal to t square by 2. Corresponding Laplace representation is rs is equal to 1 by s3 is. You have to substitute this in final value theorem. So E of s is equal to E of s is equal to limit s tending to 0 s into E of s, that is equal to limit s tending to 0 s into r of s divided by 1 plus g of s. This is a formula where you are having r of s, you have to substitute 1 by s3 s and 1 plus g of s. Now when you are doing like this, 1 s will cancel, that means 1 by s square, that means it will come 1 by limit s tending to 0 s square into g of s, that is known as 1 by ka. Ka is limit s tending to 0 s square into g of s is defined as acceleration error constant. Now types of control system. Here the control system may be classified according to their ability to follow step inputs, parabolic input, and so on. So it is known as type 0, type 1, type 2, and so on. Now open loop transfer function of unity feedback system can be written in two standard form. One is time constant form, other is fall zero form. In a time constant form, g of s is equal to k into 1 plus t z1s 1 plus t z2s. This is a common form. Here s raised to n into 1 plus tp1s into 1 plus tp2s. In pole zero form, g of s is equal to k dash s plus z1 s plus z2 divided by s raised to n s raised to s plus p1 s plus p2, like that. This is poles and zeros. The gains in the two forms are related by k is equal to k dash divided by k is equal to k dash into pi product of I zi product of j pj. I varies from 1 to j varies from the term s of n in the denominator of both the equations correspond to the number of integrations in the system. As n to 0, these terms dominates in determining the steady state error. Control system are therefore classified in accordance with the number of integration in the open loop transfer function g of s as type 0 system n is equal to 0, no integration, no pole of g of s at the origin of the s plane, no pole of g of s at the origin of s plane. So there is no, it is s raised to Here it become s raised to 0. That means this become 1. So there is no s symbol s. Symbol s means when you are equating to 0, the poles is at 0. So there is no pole. There is no pole of g of s at the origin. I told that denominator decides the poles. Numerator decides the zeros. Now type 1 system. Here n is 1. That means here it is n is 1. It indicates the number of integrations. So 1 integrations, 1 pole of g of s at the origin of s plane. So denominator, as you can see here, the denominator, as you can see here you can see 1s remaining term, here also remaining term, here also remaining term. So now in order to find the poles, what you need to do is you have to equate the denominator to 0. In that case, you will get s is equal to 0. That means the poles is at the origin. In type 2 system, n is equal to 2 integrations. That means here it becomes s square. Then 2 poles of g of s at the origin of the s plane, and so on. So type 2 system, s square is equal to 0. That means 2 poles at the origin. Now we will study the steady state error in type 0 system. Now for a type 0 system, g of s is equal to, we are using the time constant form. Time constant form here, k into 1 plus tz1 plus s into 1 plus tz into s divided by 1 plus tp1 s plus 1 by 1 plus tpz to s. Kp is, you already come across the previous page. Kp is limit of s tending to 0 g of s. So here, as you can see that Kp is limit s tending to 0, this term. Now Kp is this, so when you are doing like that, s tending to 0, this 1 plus all become 0. So denominator and numerator only k remains. So ESS, steady state error, is equal to 1 divided by 1 plus Kp. That is 1 divided by 1 plus k. It's a finite value. Kv. In order to find Kv, Kv is limit s tending to 0, s into g of s. Yeah, Kv is limit of s tending to 0, s into g of s. Kv is limit s tending to 0, s of gs. So when you are doing like that, limit s tending to 0, s into this much. So there is a product of s and s tending to 0, the all become 0. So ESS velocity, that means the steady state error velocity is 1 divided by kv, that is equal to 1 divided by 0, that is equal to infinity. Here you can see it is 1 divided by kv. So that is equal to 1 divided by kv, that is 1 by 0 infinity. Now ka, limit s tending to 0, s square into g of s. Here you can see that ka, limit s tending to s square into g of s. Now when you are doing like that, you can see that a limit s tending to 0, s square into g of s, that is the limit s tending to s square, the complete g of s. E of s acceleration is equal to, this become again 0 because s square is here. So 1 by ka, that is 1 by 0, that is equal to infinity. Now steady state error for a type 1 system. For a type 1 system, g of s is equal to, first one, type 0 system, s is 1, here 1s is there. So g of s will be modified with this term with the 1s. Kp, limit of s tending to 0 g of s, limit of s tending to 0 k divided by this term and s. So there is s in the denominator and s tending to 0, it become infinity. Now E of s position 1 divided by 1 plus kp is equal to 1 divided by 1 plus infinity, that is equal to 0. kv is equal to limit s tending to 0 s into g of s. Now you are limit s tending to 0, s you are multiplying, k the term, denominator also there is s, this ss will cancel, so you are getting k. ESS velocity 1 divided by kv, that is 1 by k, it is a finite value. Ka, limit s tending to 0, s square into g of s, so it's equal to limit s tending to s square k. This is the g of s for type 0, there is s here, 1s will be cancelled, but there is an s, so you are getting a 0 here. So ESS acceleration, that is 1 by ka, that is 1 by 0, that is equal to infinity. Now when you are dealing with steady state error of type 2 system, g of s with the other term is same, here s square. For a type 0, here it is 1, type 1 it is here it is s, in type 2 it is s square, remaining all same. Now kp is equal to limit s tending to 0, g of s, limit s tending to 0, k into 1 plus this term and s square, this will become infinity. So ESS position 1 divided by 1 plus kp, 1 divided by 1 plus infinity, that is equal to 0. kv, limit s tending to 0, s into g of s. So 1s will be cancelled, but still it is again infinity. So ESS velocity 1 by kv, that is 1 by infinity is equal to 0. Ka, limit s tending to 0, s square into g of s, limit s tending to infinity, s square, and this s square and this s square will cancel, so you are getting it as k, and ESS of acceleration 1 by ka, that is 1 by k, is a finite value. Now the steady state error of type of unit step, unit ramp, unit parabolic. For a type 0 system, unit step it is steady state error for unit step it is 1 divided by 1 plus kp, other two are infinity. Type 1 system, you can see the unit ramp 1 by kv, remaining first one is 0, unit step, then unit parabolic is equal to infinity. In type 2, first two are 0, that is unit step and unit ramp both are 0, but unit for a unit parabolic you are getting it as 1 divided by ka. So that's about the